Today we're going to talk about arrays. So this is when things start to get really complicated but interesting because we can do a lot more things. We're going to start making lists of different things. We can make lists of primitives and also lists of objects. So what is an array? An array is a data structure that can store information. They will store data, any type of data, in a list format, and they're composed of adjacent memory locations that hold values of the same type. So it has to hold all ints, all doubles, all strings, all chars, all students. It cannot hold like a double and then an int and then a string. They all have to hold the same thing. So let's consider this array, array A. So when we talk about an array, the cell is the actual, or we call it an element. It's the memory location which holds the value. And then the index is used to refer the placement of it. Now notice that it is the same as the index of a character in a string. It starts at 0 and it ends at 1 less than the length. So you can see that this one is 1, 2, 3, 4, 5, 6 long. The indices start at 0, they end at 5. So as you can see, this is the name of each element. So this refers to A of 0 refers to 0, A of 1 refers to 1, A of 2 refers to 4, and so on. This array has a length of 6 because it holds 6 elements. Indices again start at 0 and at 5. When you see these braces, these ones here, you should know that you're dealing with an array. So one of the main places that we see them is here. Public static void main string. You can see them right here. And that's saying that we are accepting, in this case, this is a method, the main method. We're accepting a string array. So this is an array of string, which is arguments. So how do we declare it? How do we create it? All right. So they have to be declared and created. When we declare it, we can declare it one of two ways. We can use the braces after the data type or the braces after the name, as long as we have those square braces. And then when we create it, we use the name becomes a new, and then we again use the data type. So if it's an int, we would put int here, double, double here. And then the length. Now, you have to put the length of an array when you actually create it. So you need to know the length when you actually when you make the creation of it. You can't leave that blank, otherwise you're going to get an error. Okay, so for the array A that we just had, you can say int square brackets A becomes new int, and then it was 6 spaces long or 6 entries long. Okay, or you can, it's the same thing, or you can switch the braces to be here. This piece is the declaration. This piece is the creation. And then just to be clear, the length, now this is very important. Once it's set, it cannot be changed. So you cannot change ever the length of an array. Okay, arrays, they also hold objects. So in this case, I used students because we use our example of students over here. And so I put 5 different students into my array. And each of these holds the actual student and all of its instance variables with it. So what does this actually look like? I want to be clear. If this is the computer, here's the array, and then this would be like at blah blah blah, at blah blah blah, at blah blah blah, at blah blah blah, at blah blah blah. Now, these all point, if this is the heap, okay, because objects live on the heap, these all point to very specific areas on the heap. So I'll use the first one as an example. Over here, that says Billy Smith, A123, 3.75, and then 2020. And the next one would be somewhere else on the heap. Isabel Hernandez. A178, 4.33, and then 2021. So primitives, as we saw over here, when you have an array of primitives, it actually holds the primitive in the memory location. When you have an array of objects, it holds a reference or a pointer where you can find that object on the heap. So just to be clear, those are two different ways. Objects are held as references in a memory location of where you can find them on the heap, and primitives are held directly inside here. That's going to be important when we come across this later. So we can also, this is the cool part about it, we can call methods on these objects by using their identifiers or their cell elements, you know, their list and their position name. So there's my array here. If I say kid at 4.getGPA, that's going to return, here is 0, 1, 2, 3, 4. That is going to return Andre Dickerson's GPA, which is 4.25. Kid at 2 get name is going to return Justin Chen, because Justin Chen is the person at kid. Kid is the object of kid at 2, so it returns that name there. Kid at 0 study 3 hours. That makes this student, we'll say Billy, study for 3 hours. Okay, an array knows its own size. We don't need to use any type of parentheses here. Like when we say with the string, we use a parentheses .length because it's a method, it has to look for its own size. But since an array's size never changes, then we know its length. So that means this here is a variable or a piece of data. Okay. So we don't use parentheses. Now, if I want to access array elements, like I just said, we access them by using the following syntax. We use the array name, the square braces, and whatever the index number. So if I use A at 2, that's the third element of array A, which in this case was 4. So that would refer to the value 4. Now, this is important. We have string index out of bounds. We also have array index out of bounds. This is an exception that happens pretty often, so we want to be clear about what it is and how to avoid it. Okay? We always want to remember that the indices of an array start at 0 and they end at 1 less than the length of the array. That's the same thing as the characters in a string. So you can see there's a pattern going on here. If you try and access an element that does not exist, so something that's less than 0 or greater than 1 less than the length, then you're going to get an index out of bounds error. So when you write loop boundaries, you want to be very, very careful about what your boundaries are so that you never hit the end of the length too far. You don't want to get into a place where you have an exception. Okay, so there's a couple different ways of how to fill an array. So in this way, you can fill it with just an assignment statement. So you can set the array elements with an assignment statement. So I just want to be clear here about what's happening in the computer. At this point with this line of code, so when we declare and create it, right now, we'll pretend this is in the computer and this is array B. It's 6 memory spaces long. And it will actually fill it with defaults to begin with. So in the very beginning, since this is an int, the defaults are all going to be 0. If you do not want those defaults to be 0 after you've created it, the very first thing you're going to want to do is to be able to fill it. So in this case, we say for int I, here becomes 0, I is less than b.length, I plus plus. What is this doing? Okay, so we're going to say b of I, okay, becomes I times I. So I'm going to hold a little table here to figure out what this is doing. So I first is 0. So then b of I would be 0 times 0, which is 0. Okay? I'm going to fill in the indices here. Now, b increments. So now b is 1, and now I'm on to this element. And so here, this element becomes, b of I becomes 1 times 1, which gives me 1. Oh. Which gives me 1, and so what is happening now is that this here is saved over as 1. And then this increases. Now we're at the end of our loop, so we increase to 2. Or we're at the end of this pass through, so we increase to 2. Now we're on this element. So we can see b of 2, which is this element, becomes 2 times 2, which is 4. And so on. So you can see that the pattern is going to be to square, that these are each the square of their indices. So then the next one would be 9, 16, and 25. 9 would fill first. These two would still be 0, 0 at this point. Then 16 would fill. This one would still be 0. And then 5 would fill to 25. Okay, or 25 would fill into that space. I think it's really important here to also notice these loop boundaries here. We started at 0. We ended at less than the length. That's a very common way to use your loop boundaries. You could also rewrite it as I is less than or equal to b dot length minus 1, but I prefer to use the one that's highlighted in orange because it's just less typing to write. There is another way to fill an array. You can fill an array explicitly during creation. It's not useful when you have a lot of different elements, so using a loop is a lot more useful when you have a lot of different elements. It's not useful when things are user-defined because the user won't be able to type in. And it's not useful when the elements are dependent on a variable value, which right here they were dependent on the variable value I. But if you would like to do that, like just quick and easy to test your code, you can totally do that. And the way you do it is, this is the declaration piece right here. So remember, int my first array, you're declaring it, and when you create it, you use the curly braces right here, and you put your values directly inside. All right, let's say you forgot to fill it. Like I just said, what happens? Well, actually what's happening in the computer is that it's getting filled with 0 for numbers, false for booleans, and null for objects at the very get-go. So if you forget to fill it, it has those default values. This is important, especially when we're talking about objects, because null for objects means we have to be careful. We could get a null pointer exception. We don't want that because it's going to crash our program. So just be very careful. You want to make sure that you fill it first. Now, creating arrays of objects is similar, but I just wanted to go over this point about a null pointer exception very specifically because I just don't want you to fall into this trap. So when we create arrays of objects, we create them in the same way as we create arrays of primitives, but be careful because when it's created, all of these are null, and because they're not yet filled, this can cause a null pointer exception. So I'm going to actually type some of this code into the side. I'm going to create a new file here in my student class, and I will call it, maybe I'll call it classroom. So public class classroom, and then maybe it holds an array of students. So I'm going to say student, and I'll say kids becomes new student, and I'm going to use the code that I wrote on the side just to show what's going on here. So right now I have 5 students in my class. So I've created it, but now these are all These are all set to null. So let's say in my main class here, where I built out a bunch of stuff, I am going to say, let's say I want to well, actually, in Classroom, I could do this. This is probably a better way to do it. I'm going to say int private int size, and then I'll say student kids. And I'm not going to fill this array just yet. So when I create my constructor, and I'll use this as the default constructor, maybe I'll put size, I'll say int size becomes, this dot size becomes size, and then perhaps I'll create an array, so I'll say kids becomes new, and here's, I'm instantiating the array. So here, this is just a declaration. It's at the top of my classroom class, so this classroom holds an array of students. So I'm going to say kids becomes a new student, and I'm going to make it of size. Okay. The size is size because let's say somebody puts 5 in here, it'll become an array of 5. Maybe they have a class of 30, so it'll be a size of 30. It's letting me generalize it so that I can change it according to whoever the teacher or administrator's needs who are filling the array or filling the class. So let's say in my main class, well, I want to do some things to fill it because I'm going to show you what happens if it's null, first of all. So maybe I want to have a method that's going to print for me some information. So I'll say public void print print class. Maybe I'll say print class. Okay. So if I want to print a class list, maybe I just want to print their names out. So I can say system, well, I want to use a for loop first of all. For, and I want to print out each one. Int I becomes 0. I is less than kids. That's the name of the list. Dot length. And I plus plus. And then I'll say system dot out dot print line kids at I dot get name. So it'll print out the names one by one. Now let's say I just want to, I'm going to title it here system dot out dot print line, and I'll just title it class list. Now I'm going to have my tester here, which is my main, and let's say I create that class of 5. So I'm going to use that code right there on the left. Student kids becomes new student. Okay. Now remember, I am not filling it yet. Okay, so let's say I want to run, oh, I didn't want to do that. I wanted to make a classroom. Classroom, my class becomes new classroom. So it created an object of the classroom class, and that in here created an array of 5 students. Okay, so what's happening here? So then let's say I say my class dot print class list, because that's something I want to do with my class. Now remember, I should get a null pointer exception because I never filled these people in. So, oh, I needed to put in a size. It's telling me there was an error, so I stopped to see what the error is. this, I only have one constructor here. Actually, this is a great example of something we talked about last section. So something that we talked about last section is if you have a constructor written, you do not get a default constructor. So here you can see that. I made a no parameter constructor. I tried to use one. It didn't give me one because I already have a constructor. So I have to use the constructor that they have, which is to fill it with my size of 5. So let's see what happens. So now I'm expecting a null pointer exception because I didn't fill them. So you can see null pointer exception right there. It's pointing me to here because I am trying to call get name on a kid that doesn't exist. So just like here, I said, oh, well, if I try and get the GPA of kid at 0, there's no kid to access. So that's the null pointer exception that we come into contact with.